Hi, this is section 1.3 on data collection and sampling techniques. Now, if you have a bunch of statistical data, there's all sorts of things you can do with it to make sense of it and organize it and present it. You can draw graphs, you can calculate averages, you can say what percentage of the data falls into different categories. But before you can do any of that, you have to have the data in the first place. So how is data collected in the first place? That's what we're going to talk about at least a little bit today in this section. Data can be collected in various ways. Telephone surveys, mailed questionnaires, online surveys. So you can ask people to answer questions or give you information by asking them to go online and fill in a survey or mail in a questionnaire. You can call them on the phone and ask them some questions. You can interview them in person. You can sometimes check records if there are records available to check. Sometimes you can directly observe situations. And all of these have their advantages and disadvantages. Some are easier or less expensive than others. Some aren't always possible. If you're trying to get people to respond to an online survey or send in a questionnaire, you're limited to how many people agree to participate, and maybe it's the people who have particularly strong feelings or who have a lot of time on their hands. Now let's talk about some sampling methods. Remember, a sample is a subset of the population. So you have a big population that you want to know something about, but there are too many individuals in the whole population for you to be able to go to every single member of the whole population and interview them or measure them or find out what's going on with them. And so you take a sample to look at. You don't want to count every single bead in the whole big swimming pool, so you just mix them up real well and you pull out a handful. And it is important to mix them up real well. If they're not mixed up real well, if all the blue beads are towards the top and you just pull out a handful from the top, you're just going to get a handful of blue beads, and that doesn't mean that all the beads are blue just because the ones you pulled out were blue. So getting a good unbiased sample that's representative of the population, that's similar to everybody else that you didn't include in your sample, is an important thing to be able to do. One sampling method is random sampling, or it's sometimes called simple random sampling, where you just use chance methods to select randomly from the whole population. So that means that everybody in the whole population has an equal chance of being included in your sample. So let's say maybe you're in charge of a fairly large company and you'd like to survey your employees, but you don't want to have to include every single employee. You just want to get a sample. So if you have a master list of all your employees, there's ways of asking a computer to randomly select names off of a list. Or if the list is numbered, there are ways of asking a computer or a calculator to give you a list of random numbers. So if you had 500 names on the list, you could ask your calculator for, give me a bunch of random numbers between 1 and 500. And so that tells you which people on the list to pick to include in your sample. Or you can just do it the low-tech way, where you write everybody's name on a card or a piece of paper and put them all in a hat and draw names out of the hat. Systematic sampling is where you select members of the population at regular intervals. So you might go down and just pick every fifth name off your list of employees, and those are the ones you use for your sample. Or you might go down to Walmart and stop every 12th customer through the door and ask them a question. Or you might check and see how many employees are absent, maybe not every day, but every third day or every 11th day or something like that. That usually works pretty well, as long as there's nothing special about the ones you select compared to the ones you don't, or as long as the selection process doesn't bias the selection. But like if you were a teacher and you decided, oh, I'm only going to check homework every 5th day, and your students knew about that, then they might only do their homework every 5th day, so that might not be the best idea. Another sampling method is what's called stratified sampling. That's where you divide the population into different groups or different categories called strata, and then you select from each group. You make sure that there's somebody from each of those different groups included in your sample. So let's say you want to know how the citizens of your city feel about something, and your city is made up of blue people and red people and green people. And if you just picked a bunch of people at random from everybody in the city, it's possible you could end up with a sample that was mostly all blue people. And then you wouldn't get the opinions of the red people and the green people. So you might want to specifically go in and select some blue people and some red people and some green people. If the city is half red and a quarter blue and a quarter green, maybe you want your sample to be half red and a quarter blue and a quarter green. If your employees are different kinds of workers, maybe you want to go in and select 5 people who are in the sales department, and 5 people in accounting, and 5 people in research and development, and 5 people in custodial services, and so forth. So you get a good cross-section of your whole company, your whole population. And then cluster sampling is where you divide the population into clusters, and then you select one or more of the clusters and you use all their members. So this might be like if your company has a whole bunch of different branch offices in the area, and instead of going to all of them, you just select maybe 1 or 2 or half a dozen of those branch offices and go to those and interview all the employees in each one of those. So those branch offices that you select would be like the clusters. And where people sometimes get confused is the difference between the stratified sampling and the cluster sampling, because they both involve dividing the whole population up into different groups. But with stratified sampling, you're including somebody, 1 or 2 or a few individuals from every one of the groups. But with cluster sampling, some of the groups are not included at all. You're just including everybody from 1 or 2 or just a few of the clusters. Now, there are some other not so good sampling methods. What's called convenience sampling is where you just use whoever's convenient, whoever's nearby or readily available. So that would be like if you just pulled out a handful of beads that were on the top of in the top of the swimming pool and you hadn't mixed them together real well. Or you just ask the employees that happen to be right around you near your office, even if they happen to be all in the sales department or all friends of yours. And then volunteer sampling is where respondents decide for themselves if they wish to be included. You let people decide if they want to take your survey or answer your questions. But if you do that, you might get a lot of people who have really strong opinions one way or the other, and you never hear from the people who maybe don't care as much, or the people who are too busy to answer, or don't spend a lot of time online if it's an online survey, that sort of thing. So let's review. Of these sample methods that we've talked about, which one are we using if we go to an elementary school and 5 students from each grade level, from kindergarten through 5th grade, are chosen to respond to a survey? So you pick 5 from the kindergarten, 5 students from 1st grade, 5 students from 2nd grade, and so on. Which sampling method would that be? Stratified. So the different grade levels are the strata, and you're including somebody, in this case 5 students, from each one of those. So that way your sample isn't all kindergartners or all 5th graders. What about if every 20th gadget manufactured is tested for defects? So when they come off the assembly line, you don't want to test every single one of them, but every 20th one gets tested. That would be systematic. What about if you ask 10 of your friends how much time they spend studying? Well, that would be an example of convenience sampling. And can you see why that might not be the best way if you want to find out, like, how much time do college students spend studying in general? If you just ask your friends, well, maybe they're your friends because you're all in the same major, you're taking the same classes, maybe those are classes that require a lot more studying than usual. Or maybe they're all your friends because you're all a bunch of party animals and you spend all your time partying and never do much studying. But your friends are maybe a lot more like you than the average college student. So you might want to get a good cross-section of college students, including freshmen, seniors, people who go to big colleges, small colleges, all different majors and things like that. And to end up the section, let me just mention the word error in statistics usually means how much you're off by when you're trying to estimate something. So if I'm trying to estimate what is the average number of hours a week that college students spend studying, and if the true average is, say, 23 hours, and I take a sample, and based on my sample, I estimate that it's 21 hours, I'm off by 2 hours. So that 2-hour difference is the error. And errors can be sampling error or other kinds of error, non-sampling error. Sampling error refers to just the difference between what you see in your sample and what you would see if you really could look at the whole population, caused by the fact that the sample does not perfectly represent the population. It's usually unavoidable to get some sampling error, but the techniques of statistics can tell you about how big you can expect that sampling error to be. What you want to take trouble to avoid is non-sampling error that's the result of things like a biased sample, when you don't pick a sample that's a good representative of your whole population, or you ask leading questions, or you use faulty measuring instruments, or something like that.